Hello, everyone. Thanks for hanging around. We are Team 6, and we're really excited to talk to you all about GeoAI models and our work this week. All right, so we all came into this week hoping to gain practical experience in applying deep learning technologies to real-world spatial problems. We all have a variety of backgrounds, but we're all pretty excited to be on the cutting edge of GeoAI. And luckily for us, IBM and NASA just released their first open source geospatial AI model a week ago. So this is a foundational model for Earth observation data. And in the remote sensing community, this is pretty groundbreaking. So a foundational GeoAI model is special because it's super flexible, which means we can apply it to a variety of spatial tasks that we're all interested in. So some examples of these are burn scar mapping, land cover change, and disaster assessment. And so this is really cool because we can take this one model that's been trained and utilize that foundation to really explore a lot of other avenues with minimal additional training. So our overarching goal this week was to explore GeoAI models.
So hello, everyone. Now I'm here to tell you about our story, which started 2 days before we came here when NASA and IBM released their model, and we jumped to run this model without having any background of it. So as you can see, our goals was like to deploy the foundational model and put it to the I-GUIDE platform, and also replicate their fine-tuned model, which means that gather the data, fix the codes, and try to build that fine-tuned model. And then finally, we wanted to create our own fine-tuned model. As you can see here, we have like the foundational model for crop classification, we have for the burn scar, we have for flood, and we use we put to run this model, and we fine-tuned for flood. And you can see the model is getting the raw imagery, satellite imagery, and try to discriminate the binary classification for no water and like water. And then also we worked with this crop classification data, which had the multi-temporal imagery with different bands, like all those images, they had like 6 bands, and try to have the crop classification. And we put the model together and fine-tune for the crop classification successfully and get the prediction data. Those have like relatively acceptable accuracy. And afterward, we decided to put and build our own novel model. And we came up with the NDBI index, which is normalized difference built up. I'm very bad with the names. So normalized build-up index. And for setting this index, we use the autos thresholding method, which was through the intensive coding in the Python. And we adapt the available flood data for this reason and mask those data to show the NDBI index in each one of them, and then use the original data, flood data, and the mask data to force the model and let's say build up our fine-tuned model. And you can see the result of here. So this is the like original imagery with 6 band, and this is our build-up area, non-build-up area based on the NDBI. And this was the fine-tuned model for flood. If you can see, model is recognizing the flood, while here model is recognizing some build-up and non-build-up area. And we would be able to successfully fine-tune our own model with our own idea for this project But before I have to specifically thank from Rajesh, because without him, we won't be able to, without his support, we won't be able to run this model and reach this success. Now I'm gonna ask my colleague.
So this is our contribution. So in terms of the ethics, we mainly focus on 4 different ethics methods, which are auditability, honest representation, explainability, and unintended use. Among them, we would like to emphasize about the auditability, that we have the data card and checklist, Jupyter Notebook, so that the user can easily follow our instruction and learn our model. So during this summer school, we are able to advance GeoAI research based on the reproducibility and collaboration. So this we have 4 different Jupyter notebooks that have user can easily follow our model, and they can reproduce their result. And this is our presentation. Thank you for listening.
So this was for the time, because we also fine-tuned for the Berniscar, and you can see these beautiful images. And I'm seeing we have still 4 minutes. That's why we know this is very interesting model, and you might have questions. Yes.
This is super cool. I have a question about Berniscar. What scale does this really work down to? I'm curious, does it have to be a certain area before the AI can detect it? Have you played around with scale for this kind of detection?
So this model was trained on harmonized Landsat Sentinel data. So right now it's really only able to use it at that 30 meter pixel resolution. The concepts of it recognizing certain spectral signatures are wide ranging. So I think that's a really interesting area for future assessment to see if it can pick up more fine spatial resolution imagery.
Thanks for a great talk. On the urban binary classification, where did you focus on regionally, and how applicable do you think that would be to, say, the global south, where there's informal settlements that don't necessarily form the same structures and have the same detail as they do in the United States, for example?
So as she mentioned, this model is using 6-band satellite images, and this has 30-meter, let's say, resolution. But it is fairly applicable if you can prepare those GeoTIFF data, which we were in the shortage of time, we were not able to find so many, thousands of them. But if you can prepare them, thousands of them, for example, to feed the model for build up and non-build up area, I think that model would be very useful and applicable, let's say.
So for someone who is exploring this tool for this suite of tools for the first time, how easy or hard it is to get access to it and start working on it?
That is a good question, because it was we jumped in and we found out so many things. If you go through all the AI models, they are not documenting what the problem is, but we try to document all the possible problems, and they are on the, let's say, Jupyter notebooks. But still, you probably need to fix some errors, because in the part of time we found out that our GPU, for example, capacity is not that large. You have to adapt with your type of GPUs, your codes. I can say it is fairly hard, but we try to make it as simple as possible.
So I have an ethical question around the answer to Andrew's question, which is do we want AI to have thousands of images of illegal settlements and colonies, even here in the US?
in other places, refugee camps in conflict zones. What do we do about that? You don't have to answer this. This is to the whole group. Like Eric's running an AI for good, but can that really be for good?
Yeah, I won't bias the judges except to say that that question has been asked before, and it was asked at the AI for Good conference as well. So that is something that's being talked about for sure.